Let's go. Here's tutorial number 15, solving quads using completing the square. We've looked at a lot of different ways to solve quadratic equations, and this is going to be the last one we look at. And before we get there, we're going to talk real quickly about perfect squares. Perfect squares, I'm talking about numbers like 4, right? 4 is a perfect square, and the cool thing about 4, it can be represented by something times itself. 2 times 2, and that's what makes 4 a perfect square. What's the next perfect square you can think of? That's right, 9, right? Because 9 is the same thing as 3 times 3. We can write it with parentheses instead of the dot, right? And then we know 25, et cetera, et cetera. All of these are called perfect squares because they're equal to a number times itself. So, 100 and 49 and 121 and 64, 16. There are an infinite amount of perfect squares. All right, why am I talking about perfect squares? Well, I want to transfer that idea of something being a perfect square because it can be represented by something times itself to trinomials. And we know that trinomials are something that is 3, right? There's three terms in a trinomial. So a perfect square trinomial is going to be an interesting trinomial, like x squared plus 6x plus 9. Yep, it's a trinomial. Now, is it a perfect square? Well, let's think about it. If we factored it, which we're going to, and we thought about two numbers that multiply to equal 9 and add up to equal 6, what are those two numbers we think of? That's right, plus 3 and plus 3. Oh my gosh, this is a perfect square trinomial because x squared plus 6x plus 9, this trinomial can be represented by something times itself. So it's called a perfect square trinomial. Let's see if we can think of another perfect square trinomial. This time, let's use a minus because I want you to know that we can also, our middle term can be a negative. Let's see, let's put minus 8x plus 16, right? Let's see if this works. So you'll notice in a perfect square trinomial that although the middle term could either be a plus or a minus, that end term, there's two things, right? We gotta have to have a plus, and we're going to have a perfect square at the end. All right, so here we go. How are we going to factor this? Well, we're going to think of two numbers that multiply to equal 16, but add up to equal negative 8. So that's right, we're going to do negative 4, right? Negative 4 times negative 4 is positive 16, and negative 4 plus negative 4 is negative 8. So that's why this, too, is a perfect square trinomial because it can be rewritten as something times itself. All right, so now you know what a perfect square trinomial is, which is important to know when we're solving by completing the square. Okay, spoiler alert. I'm going to tell you straight up because some of you are going to notice it right away. These problems that we are doing, these quadratics, can be solved by factoring. All right, the secret's out. We are taking an easy approach to learning completing the square so that we get integers as answers. But know that on the test, even if you can factor, if it says solve by completing the square, you need to do that. And why? Well, because in future math, we're going to be completing the square where the answers are let's just say they're irrational. And they've got radicals in them. And we're going to learn that completing the square is easier than using quadratic formula. But for now, for this year, because Algebra 1 is a building year, right? It's a foundation year, we're going to learn completing the square with pretty numbers. All right, are we ready? The first thing you're going to ask yourself is x squared minus 8x plus 12, is this, and apparently having trouble with my marker. All right, is this a perfect square trinomial? You're like, no, Miss Overby, 12, because that's the first thing we're going to look at. 12 is not a perfect square. So what we're going to do is we're going to kick 12 out to the other side. We're going to go ahead and subtract 12 from both sides. And ending up with x squared minus 8x. We're going to leave a big blank here. In fact, I'll write a line. And we're going to create, on the left side, we're going to create a perfect square trinomial. Okay, that's what we're going to do. That's why it's called completing the square, because we're making something into a perfect square trinomial that wasn't to begin with. All right, how do we do this? Well, there's a method for it. It's not a formula, it's a method. And step one is always take the middle term. So we're going to take that middle term, -8. Step two, so if you want to write down any steps, if you like steps, step one is take, and it's not middle term, middle terms coefficient. I'm running out of space. Okay, so always going to look at the middle terms coefficient, that's -8. Step two is we're going to divide it by 2. It's worth writing down these steps because we're going to do them every single time we're completing the square. So we take the middle terms coefficient, we're going to divide it by 2. So in this case, that gives me, what, -8 divided by 2 gives me a -4. Okay, and then step 3, square it. You don't have to do the exclamation mark if you don't want to, if you don't want to get excited about squaring it. So we're going to take the -4, we're going to square it, and that's going to give me 16. This is what I'm going to use. Ooh, let's go with red. This 16 is what we plop in here. Plus, it's always going to be a plus. Remember, we talked about y, plus 16. Look at us. Look how cool we are. Okay, this calls for a new color like that magenta. That was a pretty cool color we used last. I don't know when we used it. All right, so what we just created on the left side is a perfect square trinomial. And we know that we did because think about it, if we factor it right now, right? If we factored it, two numbers that multiply to equal 16 and add to equal -8, that's -4 and -4. Now, I'm going to include this step this time so that you understand what's going on, but we're going to skip this step from here on out. So I'm going to go ahead and factor it. I'm going to bring down the equal. I'm going to bring down the -12. And then I'm going to say, oh, wait a minute, Miss Overby, hold on. You just added a 16 into the left side of the equation. Now it's not an equation anymore. It's not equal. Oh my gosh, you're right. What should I do? Thank you. I've got to add. I almost skipped this step. Crazy, right? I'm writing so many things down here, I got distracted. Because I added a 16 into the left side of the equation, I have to add a 16 into the right side. So -12 plus 16, let's get back to that great magenta color. -12 plus 16 is 4. All right, so let's stop here for just a second, because this first one, just like everything else, it's going to seem a little bit overwhelming until we really stop and repeat ourselves for a second. First thing, what did I do? I looked at the left side, I said, that's not a perfect square trinomial. Let's kick out that 12. So we subtracted 12 from both sides. Second step, I created a perfect square trinomial by using these 3 steps. But then I almost forgot, right? I plopped in that 16 that I got from doing the 3 steps. And if I plop it in on the left to keep it equal on both sides, I got to plop a 16 in on the right. And so then I noticed, yay, I did make a perfect square trinomial on the left. I'm going to factor it. -12 plus 16 is 4. And now I'm going to go ahead and rewrite x minus 4 times x minus 4. How can I rewrite that? That's right, x minus 4 quantity squared. And why would I want to do that? Well, once I do that, then I notice that I can use the square root method to solve. So I'm going to go ahead and take the square root at both sides. And of course, I always remember when I take the square root of both sides, even if there's no room, I put that plus or minus. All right, square root of x minus 4 quantity squared is just x minus 4. And then I've got plus or minus 2. And now I'm going to split it up. I've got x minus 4 equals 2. X minus 4 equals -2. I'm going to go ahead and add 4 to both sides, so x is equal to 6. I add 4 to both sides here, x is going to be equal to 2. All right, so what did we just do? We solved for x using a new technique that's called completing the square. It seems, I know it seems like a lot, but trust me, by the 4th one, we're going to be okay. So let's just quit talking about the first one and let's move on. All right, so let's look at the left side. First of all of a sudden this one's different, right? Because we have a 3 on the right side. Look at this first one, I had a 0 on the right side. The second one, I have a 3. Irregardless, right now, I do not have a perfect square trinomial, do I, on the left. So we're going to kick out the 38. So let's do it. Let's kick out the 38. and I'll end up with b squared plus 12b. I'm going to put a little blank. Negative 38 plus 3 is negative 35. All right, now we're going to do our 3 steps. So step 1 is take that middle term, the second term's coefficient, that's 12. Step 2 is cut it in half. 12 divided by 2 is going to give me a 6. Step 3 is square what I got. So square the 6. 6 squared is 36. And that's what we put in here. And then, okay, is it a positive? Yes, it's always going to be a positive. When we square a number, we're always going to get a positive number. All right, so, oh no, I dropped a 36 on the left side. To keep it equal, what do I have to do on the right side? That's right, I got to drop a 36 in over here. All right, I created a perfect square trinomial, or I didn't do it by myself. You helped me, right? I mean, kind of. So this is a perfect square trinomial. Now, remember what we did last time? We went ahead and factored, and we could do the same thing if you like that step. We said b plus 6, or we will for this, b plus 6 times b plus 6. But I'm going to go straight to the factored form. So here's what's going to happen. We're always going to take the square root of b squared to put b. We're always going to take this sign to put the plus, and we're always going to take the square root of this to put here. All right? If you didn't like that, then get the other step. Remember the first one, how we did this step right here? And if that made more sense to you, then do it. Do that step. I'm just giving you an alternative way to do it to skip a step. All right, negative 35 plus 36 is 1. Yay! We can use the square root method, so let's go. We're going to go ahead and take the square root of both sides. We're going to remember to put a plus or minus in front of 1. So we get b plus 6 equals plus or minus 1. Whenever we have a plus or minus, we need to split it up into 2 equations, because that's what we have, right? Either b plus 6 equals a positive 1, or b plus 6 equals a negative 1. If I subtract 6 from both sides, I get b equals negative 5. Subtract 6 from both sides, I get b equals negative 7. So there we go. We're using completing the square as a, let's see, how many different ways have we done? We've done factoring to solve a quadratic. We've done square root method to solve a quadratic. We've done quadratic formula, and now completing the square. Once again, yes, all of these problems that I'm doing completing the square on could be solved by factoring. But really, do you want to learn completing the square where we get yucky answers? I didn't think so. So be happy that our answers are nice. All right, solve by completing the square. Let's go. All right, so, oh no. Oh no. Okay, first of all, what in the heck? This is different. I've got a 3 in front of that x squared. Did I have an integer? I'm sorry, did I have a coefficient in front of my first term? No, I haven't seen that before. So what I'm going to do is I'm not going to freak out. All right, well, because I know what to do. But it's never good to freak out, is it? So I'm going to kick out, because this is far from a perfect square trinomial, I'm going to go ahead and kick out that 20 first. And then I'll deal with what's left, okay? I'm going to go ahead and leave this spot and see what I got. All right, so, oh my goodness, I did 2 x's. What do you guys like this up with me? Come on. So here we go, 3x squared. All right, here's the deal. We cannot do our 3 steps as long as we have a coefficient that's not 1 in front of the x squared. Okay, as long as we see a number in front of the x squared, we're in trouble. We got to get rid of that. So can you think of a way to get rid of it? Let's see, this term's got a 3 in it. This term's got a negative 6. This term has a 24. I think that we probably have a GCF. What do you think? All right, checking on the time. We do. What's the biggest number that goes into all 3 terms? You got it. It's 3. So what we're going to do is we're going to divide every term by 3. Don't worry about our block there or our spot there. We'll come back to that. So we end up with an x squared minus 2x. We got our line there equals 8. Can we complete the square now? Absolutely, which is awesome. All right, so step one is take that coefficient in front of your middle term, that's -2. Step two is divide it by 2. Yes, I know it's negative. We can deal with it because step three is square that. A -1 squared is a +1. Take that number and plop it in. If I plop a +1 in over here, you better believe I have to plop a +1 in over here. I'm going to skip that step. I can't decide, since I can't hear you, whether you like that I skip it. So maybe this time, maybe I'll alternate. This time I'll go ahead and factor. So I've got, this is a perfect square trinomial, which it is. -1 times -1 gives me a +1. -1 plus -1 gives me a -2. And I can rewrite this, just like I can rewrite x times x as x squared, I can rewrite that as x minus 1 quantity squared. And yay, 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 I get to do the square root method and solve. So I get x minus 1 is equal to ±3. Break it down because we have two equations in one, don't we? X minus 1 equals 3, and x minus 1 equals -3. Plus 1 plus 1, x equals 4, plus 1 plus 1, x equals -2. Okay, did I say this? I want to repeat it. On the test, when it says solve by completing the square, even though you're smart enough to see we could factor, you've got to show that you understand the method of completing the square. And then I trust you, your reward will be when you take Algebra 2 Trig, you'll have lots of messy answers. But this year, nice answers. Here we go, our last one. Oh no, every problem has to have something different about it, right? And here's the different thing. Our second term is really our last term. It's like this is not in order. Let's get ourselves in order right now. So what I'm going to do is this. I'm going to go ahead and I'm going to kick the 32 out. It belongs over there. So let's do this. Let's kick the 32 out. So we've got the x squared. I really want to do both of them at the same time, but I don't want to overwhelm anybody. All right, so I have to write it like that, right? Because 12x and -32, they're not like terms. We can't combine them. And I want to get that 12x where it belongs. It belongs on this side. All right, so sometimes you're going to see problems like this where you're going to have to do some housekeeping first before you can even start completing the square. And that was get the 12x over by subtracting on both sides, get the 32 kicked over to the other side by subtracting it from both sides. All right, here we go, completing the square. Step 1, take that middle term's coefficient. Step 2, take that number, divide by 2. Step 3, take that number and square it. We get 36. Bam, we're going to drop it in here. And we've learned the hard way that if we drop in something on the left side, we're going to drop it in on the right side. If we don't, we're not going to get the answer right. And then we probably go back and figure out our mistakes. So yay, we've got a perfect square trinomial over here. I'm going to go ahead and skip that one step I normally do, square root of x. Square root of x squared is x, that's a negative. Square root of 36 is 6. Plop that square up there. -32 plus 36 is 4. And now let's go ahead and square root both sides. Don't forget your plus or minus. So we'll have x minus 6 equals plus or minus 2. That's two equations hidden in one. X minus 6 is 2. X minus 6 is -2. Add that 6. X equals 8. Add that 6. X equals 4. Bam. We are getting good at this. All right, so you know practice makes perfect. I think that was our last one. It was. Please spend your time practicing and checking your answers online. I look forward to working with you with marker boards. All right, thanks for joining me.